Our universe is a vast and mysterious place. It's filled with wonders that both inspire and confound us. We humans have always sought to understand the cosmos. We crave predictability, a sense of control. But some aspects of our universe are inherently unpredictable. Even the smallest actions can ripple through time and space. Imagine a butterfly, its wings a delicate dance of color. Could this creature influence the path of a hurricane? This is the essence of the butterfly effect. Chaos theory delves into dynamic systems sensitive to initial conditions. These systems are governed by a balance of order and disorder. Chaos theory reminds us that predictability is not always within our grasp. Join me as we journey into the realm of chaos theory. We'll explore the butterfly effect in the dance of cause and effect, embrace the unpredictable to deepen our understanding of the cosmos. Chaos theory doesn't mean that our universe is random or without order. Instead, it reveals a universe of intricate interconnectedness, where even the smallest of changes can lead to dramatically different outcomes. It's a universe where the flap of a butterfly's wings in Brazil can indeed influence the formation of a tornado in Texas weeks later. This concept of sensitive dependence on initial conditions is a cornerstone of chaos theory. It suggests that even the tiniest discrepancy in the starting point of a system can amplify over time, leading to vastly different outcomes. Think of a game of billiards. A slight change in the angle of the cue stick can send the ball scattering in entirely different directions. Chaos theory challenges our traditional notions of cause and effect. It suggests that simple, linear relationships between events don't always hold true in complex systems. Instead, we must embrace a more nuanced understanding of causality, one that acknowledges the intricate web of interactions that shape our world. The butterfly effect is more than just a whimsical thought experiment. It's a powerful metaphor for the interconnectedness of our world and the profound implications of even the smallest actions. It reminds us that we are all part of a complex web of relationships, and our choices, no matter how insignificant they may seem, can have far-reaching consequences. Imagine a single grain of sand on a vast beach. Now imagine that same grain of sand triggering a chain reaction that ultimately leads to the formation of a magnificent sandcastle. This is the essence of the butterfly effect. The idea that seemingly inconsequential events can have a cascading impact on the world around us. The butterfly effect isn't about assigning blame or suggesting that we can control the course of events with absolute precision. Instead, it's about acknowledging the inherent unpredictability of complex systems and recognizing that even small actions can have a ripple effect. Section 4. Weather prediction, a chaotic symphony of air and water. Few things illustrate the principles of chaos theory better than the weather. Our atmosphere is a dynamic, ever-changing system, influenced by countless factors, from the sun's energy to the Earth's rotation. It's a system where even the smallest variations in temperature, pressure, or wind speed can have a profound impact on weather patterns across the globe. Weather forecasting, for all its advancements, remains an imperfect science. This is because the atmosphere is a prime example of a chaotic system. Even with sophisticated computer models and vast amounts of data, predicting the weather with absolute certainty beyond a certain time frame is incredibly challenging. The inherent unpredictability of the weather serves as a constant reminder of the limitations of our understanding and the need for humility in the face of complex systems. It also highlights the importance of adaptability and resilience in a world where change is a constant. Section 5. Pendulums and populations, chaos in motion and numbers. The principles of chaos theory aren't confined to grand, complex systems like the weather. We can also observe them in simpler systems like the motion of a pendulum or the fluctuations of animal populations. A double pendulum, for example, is a seemingly simple device consisting of two pendulums connected end to end. However, its motion is surprisingly complex and unpredictable. Even slight variations in the initial conditions, such as the starting angle or velocity of the pendulums, can lead to vastly different trajectories. Similarly, the populations of animal species in an ecosystem can exhibit chaotic behavior. Factors such as predator-prey relationships, resource availability, and disease outbreaks can interact in complex ways, leading to unpredictable fluctuations in population numbers. These examples demonstrate that chaos theory is not just a theoretical concept confined to textbooks. It's a fundamental principle that governs the behavior of systems both large and small, from the grand dance of celestial bodies to the intricate workings of the natural world. Section 6. Pioneers of Chaos. From Poincaré's insights to Lorenz's butterfly. The development of chaos theory is a testament to the power of human curiosity and the relentless pursuit of knowledge. It was born from the work of brilliant minds who dared to question conventional wisdom and embrace the beauty of complexity. Henri Poincaré, a French mathematician and physicist, is considered one of the forefathers of chaos theory. In the late 19th century, while studying the three-body problem in celestial mechanics, Poincaré realized that even seemingly simple systems could exhibit incredibly complex and unpredictable behavior. Edward Lorenz, an American mathematician and meteorologist, is credited with popularizing the concept of the butterfly effect. In the 1960s, while working on weather prediction models, Lorenz discovered that even tiny rounding errors in his computer simulations could lead to drastically different weather forecasts. These pioneers of chaos theory, along with many others, helped to usher in a new era of scientific thought, one that embraced the interconnectedness and inherent unpredictability of our universe. Their work continues to inspire scientists and mathematicians today, pushing the boundaries of our understanding and challenging us to see the world in new and unexpected ways. Section 7. Chaos and Us. Living in a universe of unfolding possibilities. Chaos theory offers us more than just a new way of understanding the universe. It also provides a framework for navigating the complexities of our own lives. In a world that often feels overwhelming and unpredictable, chaos theory reminds us that uncertainty is not something to be feared, but rather an inherent part of the fabric of existence. It encourages us to embrace the present moment, to find joy in the unexpected, and to approach the future with a sense of curiosity and wonder. It teaches us that even small actions can have a ripple effect, and we have the power to make a difference in the world, even if we can't always predict the outcome. So the next time you see a butterfly fluttering by, take a moment to appreciate the beauty of its delicate wings and the profound implications of its seemingly insignificant flight. For in that butterfly's dance, we catch a glimpse of the intricate and unpredictable nature of our universe. A universe where chaos reigns and possibilities are limitless.